Okay, we are working on this thing right here. Yes, sir. So what this is motion modeling, and we're throwing a water balloon. So we're modeling that with a parabola. So where is my picture? Right here. Okay, so what we have is a 48-foot tall building. We throw a water balloon off of the building, so we'll pretend that here's the building, right? And so there's a window, there's another window, here's the door, and we're on top, right? We throw the water balloon off the building, and it goes up, and it comes down, and splashes on somebody down here, right? So, what we want to know is the maximum height of the balloon, so that would be the vertex, right? This one's the vertex. How long does it take to hit the ground? That would be, this one is the y value of the vertex, right? The y value. And then how long does it take to hit the ground? That would be the x value of the x-intercept. Value. There we go. And then how high is it after 2.5 seconds? We plug 2.5 into our equation. This is the x value, and this is the y value, right? This is x. So when x goes into your equation, what's the y value? And then during what time period will its height exceed 55 feet? This is the y value, and we're looking for the x value. In fact, two x values, because we're at 48. It goes up past 55 to get to the top, and then it comes back down, right? And so this is what we're looking at, right? This is the idea, what's going on. So we're going to need to find the vertex. We're going to need to find the x-intercept, the positive x-intercept, because there's another, the parabola's over here too, right? But we don't care about this side of the parabola. This doesn't mean anything. We care about the x value of the x-intercept on this side, the positive x-intercept, and then these other numbers are values that we're going to find. So we need to write the formula. So let's do that. So we want to get rid of this business here, for a second anyway. All right. So let's go and pick another color, eh? All right, so 1/2 of g. So g is gravity. And gravity depends on, the way we write the equation depends on what you're measuring with. In this case, we're measuring with feet. So we're going to use this one right here. So the formula is 1/2 of gravity, negative 1/2 of gravity, right? Make sure we do that. Negative 1/2 of gravity. So here's 32. Half of 32 would be 16. Negative 16 t squared plus. Now then, the velocity, they tell me the velocity is 32, so we're going to put 32 in there. So it just so happens that the speed of gravity, the acceleration of gravity when it falls down is the same as what you're throwing the ball at. This doesn't have nothing. This number here had nothing to do with this number here. This is 32t. And then off the top of a 48-foot tall building, so that means the y-intercept right there is 48. So we're going to put 48 right there. So this is the equation of the parabola that we're dealing with, right? And we want to be able to find the vertex. We want to be able to find the x-intercepts. We want to be able to find where it is. And we're going to use the calculator to do all of that. So let's do it. Turn it on. Oh, I still haven't cleaned my batteries out. Negative 16 x squared, whoops, 32. 32x plus 40. There we go, 48. What am I doing? Okay, negative 16x squared plus 32x plus 48. So I use x in here because that's the way the calculator works. Here t stands for time, g stands for gravity, v is the velocity, the initial velocity, and then h is the initial height. Okay, so when we graph it, it's going to look just like that. So we should probably get rid of that graph. And where's my eraser? There we go. We'll get rid of this graph. I hope. There we go. And we'll get one for ourselves. Now then, we want to be able to see the whole shebang. So we need to go up. I'm pretty sure that it says we need to go up to like 70. So we'll put 70 in there. Negative 10 right there. So what I'm doing is I'm making my window go from negative 10 to positive 70, and Y scale I'm going to count, let's count by 10. There we go. So it's going to go 10, 20, 30, 40, 50, like that. So where's my little pointer? Here we go. So this is 10, 20, 30, 40. You know, that's 48, so there's 50 right there. This is 1 second. This is 2 seconds. The x value is measured in seconds. And then that's the height right there. Okay? So, whoops, we've got to be able to see that. There we go. Is it better with or without that bright light? Let's see if we can make it work, huh? No, I don't think so. Oh, I can see the paper pretty good, but I can't see the calculator. Let's try again. And might have to have that bright light on there, huh? Let's see. Maybe we can get something. There we go. Nope. Okay, come back, bright light. We'll deal with it. Okay, so the graph looks like that. That's the graph right there. Now then, what I want to do is I want to be able to find the vertex, right? So check this out. If you do second trace, there's a menu, and they ask you if you want to find the maximum, and yes, I do, because the maximum is the y value, right? So it says get on the left bound. So I have to be on the left side of where I think the top of the mountain is, and so I'm already there, so I can hit enter, or I can slide up a little bit and hit enter. It doesn't matter. I'm going to hit enter right there. Now then, it says right bound. That means you have to be on the other side. You have to bracket the maximum. So I'm going to hit enter. And then it says guess. Where do you think it is? And so I'm just going to guess. As long as you're in between, you can guess anywhere, and it'll tell you the answer. So down here at the bottom, this says 164. So the coordinate of my graph, the coordinate of my vertex, what happened to my vertex? Yeah. Okay, so I'm going to draw my picture over here again. The coordinate of this vertex is 1, 64. So what does that tell me? that tells me that after 1 second, it's the highest it's going to be. And what is that height? It's 64 feet. Now remember that you have to write the units that you're measuring with. This one's measuring in feet, right there. We decided that was feet. So your answer has to be in feet. Now then, how long does it take? That's going to be seconds. Remember, this is 1 second. Here's the building right here. Right? This is the top of the building. I throw it off the top of the building. It comes down here and it squishes somebody way down there. Splashes on somebody way down there. So how long does it take to hit the ground? That is the x-intercept. Now, the quadratic formula is a really fast way to find the x-intercept. So let's do the quadratic formula. So I'm going to go to Program. I'm going to go up to Quadrat, which is the one I put into my calculator. And there it is. The x was negative 16. The A number is negative 16. The B number was 32. And the C number was 48. Hey! So this tells me that there's two x-intercepts. One of them's positive and one of them's negative. I don't want the negative one because that doesn't mean anything in this picture, right? So the positive one is the one that means something. So that means this coordinate right here, is 3, 0, right? Now, like I said, there's another x-intercept over here, but the parabola didn't come up out of the depth of hell and go up here and then come back crashing down. And this is the water balloon that we're throwing off the top here. It doesn't continue. It stops right here. It starts right here, and it stops right here. This negative x-intercept doesn't mean anything in our modeling problem. Okay? So 3 is the answer that we're looking for right here. And how long does it take? It takes 3 seconds. It takes 3 seconds for it to go all the way through its whole trajectory and then splash on the person, unsuspecting person down here. Right? How high is it after 2.5 seconds? That's one thing we can deal with. Now remember that one thing we can do is we can plug 2.5, because x is 2.5, right? We can plug 2.5 into t, t is 2.5. So I can put 2.5 here and square it, times negative 16, and then I can put 2.5 here times 32, and then plus 48. That's going to tell me how high it is after 2.5 seconds. Or I can use my calculator, which I want to do. So I'm going to hit my graph button again. There it is. And then I'm going to go to the second calculate. Right? Just showing you this menu right here. Today, this whole thing is about the calculate menu. So I want to know the value. That's what I'm interested in. Number 1. So I'm going to hit number 1. So if I put 2.5 there, that's going to tell me where it is after 2.5 seconds. So I hit enter, and it shows me the little cursor right there that after 2.5 seconds, it's already reached the apex and it's falling down. It is, what does that say? 28 feet. You can't read that, can you? 28 feet off the ground. So this value right here, how high is it after 2.5 seconds? 28 feet. And then during what time will it exceed 55 feet? Well, we know that it started at 48, it went up to 64, and then it went back down to 0. So somewhere in here is 55. So I'm going to do just that. I'm going to draw a line at 55. So if I draw my line at 55, can you see that? Yeah. You can see that on the way up,
it hits 55, then it goes all the way up to 64, and then on the way back down, it hits 55. So we want to know where that is, right? Now we can use the calculator to find it. We just do second calculate. So we're interested in this menu right here, the calculate menu, second calculate. If you go down to number 5, it says intersection, right? So I'm going to do that. I'm going to go down to number 5. And it says first curve. So I'm on the first curve. The first curve that I drew, the first curve that I put in my calculator is the parabola. So am I on the first curve? Yes. So I hit enter. Now the second thing I drew was this line, and I say yes, I'm on the enter. And then it says, where do you want it? It says guess. Oops, you can't see that. Guess. So there's 2 intersection points, so I have to be on one. And it'll tell me that this one happened at 0.25 seconds. At 0.25, it was 55 feet high. 0.25. So 0.25 is one of these values. So I'm going to say between. What time period was its height above 55? So between, that's a W. Between 1/4 of a second, 0.25 seconds, It's hard. There we go. And between 0.25 seconds and what's the other value? Well, I go do the same thing again. Second calculate. I'm using my calculate menu. Number 5, intersect. Am I on the first curve? Yes, I'm on the parabola. Am I on the second curve? Yes, I'm on the line. Guess, where do you think it is? I'm going to guess over there. 1.75. 1.75 is what that says. 1.75. Okay? So I can put 1.75 right there. Seconds. So during what time period will its height exceed 55 feet? From 1/4 of a second to 1 3/4 seconds. Right? That's what they're asking. If I asked how long is it above 55 feet, then your answer would be to find these two and then subtract them. It would be above 55 feet for 1.5 seconds. 1.5 seconds of its travel, it would be above 55 feet. Right? Remember, it traveled for 3 whole seconds. So that's the answer to that one. Let's do another one. Let's do this one. So we need to clean out all this junk. So can I get it all at once? I don't think so. No. We'll just do a little bit of erasing here. Ta-ta-ta. And then okay, so we're dealing with meters now, right? So we're still using the same formula. Whoops. This one, we're not using this formula. Ha ha ha. And so this is the acceleration of gravity that's measured in feet. The other acceleration of gravity is measured in let's see, is this a color we can deal with? Yeah. Okay. So this one is measured in meters, right? Since we're dealing with meters here, right?
The velocity is, I'm going to have to erase my parabola because it's in the way. Okay, so I've got my initial velocity is 33 meters per second, and it's thrown upward from 1 meter, right? So let's grab this guy and see what we can do. I don't think we want green. Okay, so the velocity is 33, so that's this value. 1 meter is the starting height, right? So half of gravity. Well, gravity is 9.8. So if I do negative half of 9.8, half of that, that's 4.9. So y equals negative 4.9 x squared t squared. Oh, we'll just leave it x. I have to type it x anyway. Plus 33x plus 1. Remember, why is the 1 there? Because it says that's the starting height. And why is the 33 there? Because that's how fast I threw it. Right? There we go. What's the maximum height of the ball? So the graph's going to look the same. We're going to start at 1. This is 1 meter high. It's going to go up, and it's going to come down, and it's going to hit the ground. Right? How long does it take to hit the ground? High as it is for 1.4 seconds. And then, what's the other one? We'll just scoot it up here. During what time period will its height exceed 50 meters? Okay? So that's what we're interested in. Let me get rid of some of this junk. It's in my way. And then we will just write the whole thing again. Okay? So we know that the thing was, I didn't like red, I'm going to go with blue again. So y equals negative 4.9. Where'd that come from? Remember, that's half of gravity when you measure in meters. Plus 33, that's the velocity, it says so right there, 33x plus 1. Alright, so maximum height, that's the vertex, that's what we're interested in. How long does it take to hit the ground? That's the x-intercept. This is the value, you put 1.4 into the problem, and then when will it exceed 50? So, let's look and see. So, I need to go y equals, I have to clear this out, and now then, I'm measuring negative 4.9x squared plus 33x plus 1. That is the deal. Okay? Graph. And let's see if we can see something. Oh, we can. Okay, so now my window's not wide enough to see the whole thing. I can see the vertex, but I can't see the other x-intercept, which is over here somewhere. So I need to make it wider. So I'm going to come over here and make this wider. So I'm just going to multiply, or just make it, let's make it 10. What do you say? Let's see if that works. 10 is too far. What did I do? What? Where's my thing? Oh, I made it 107. Ha! That doesn't work. Clean that out, and now let's go. Da 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 da. Okay, beautiful. I think that's magnificent. So we can see it does hit the ground right here, and it doesn't drill a hole in the ground. You know, once the first flight of the parabola, it probably, if it's a ball, it's going to hit the ground and then bounce again and make another parabola, and then bounce again until it starts rolling. Right. So the deal is the first bounce is this parabola right here. That's the first bounce. Okay, so we're interested in the vertex. That's the maximum.
I'm going to go to maximum. I'm going to hit 4. It says left bound. So you can see the cursor's already somewhere on the left. That's cool. I'm going to hit OK. Then it says right bound. Remember, anywhere on the right. You don't have to be exactly in the same place that one was. You can be way down here if you want, as long as you're on the right-hand side of the top of the parabola. And then anywhere in the middle, whenever it says guess, anywhere in the middle works. So as long as I'm, close to the middle, I'm happy. Now it's going to tell me that the maximum happens at 3.367. So 3.367 seconds after I throw the ball, it's at 56.56 feet. So when I say what's the maximum height, oh, it's not feet, it's meters, right? Almost made a horrible mistake. Oh, it is 56.56 meters. So don't forget to write the units. If you write feet when it's supposed to be meters, you'll be marked wrong. If you write meters when it's supposed to be feet, you'll be marked wrong. And if you don't write anything, you'll be marked wrong. So you have to choose which one it is. And it tells you in the problem. See, that's meters, meters. So you know what it is. Okay, how long does it take to hit the ground? We want to find the x-intercept. Now, we can do it with the calculator using the intersect menu. So let's do that. 0. So y equals 0, that's where we're looking for. And then if I graph my picture, I have to find the intersection of those two lines. So I'm going down to number 5. And I hit enter. It says, are you on the first curve? Yes, I am. Am I on the second curve? See, I'm right there on the x-axis, so yes, I am. And then guess, where do you want? Now there's a left one and a right one. All I care about is this right one right here. So I'm going to find that one right there. And what does that say? 6.765. How long does it take to hit the ground? 6.765 seconds. Still measuring in seconds. Whenever we measure in meters, we're still measuring in seconds. How high is it after 1.4 seconds? I say, I go to calculate menu. It's the value button. It's the very first one. I say 1.4. And you can see it's on its way up, right? So if I asked you to comment on the position and or on the position of the ball at 1.4 seconds, you would say it's on its way up and its height is 37.596. 37.596. We might even round that off. So, how high is it? 37.6 meters high. After 1.4 seconds, that's where it is. And then, when will it exceed 50? Remember what we did? We come down here. We had type 0 in to find the x-intercept. But we're going to type 50 in to find the place. How long is it above 50? Now remember, it goes up to 55, right? Or 56, 56 and a half. So it starts at 1, and then it goes up, and then it comes down. So it goes past 50, comes back down. What are those two values? I'm doing the intersect menu, which is number 5. It says, are you on the first curve? Yes, I am. Am I on the second curve? Yes, I am. And then I have to slide over to where it is in that spot, 2.21. So we're going to, oh no, what happened to my, there we go, 2.21. So we're going to say all the time in between
2.21 seconds, and
what's the other one? That's the question. So I do second, calculate, down to intersect. It says, are you on the first curve? You have to make sure you're on the parabola. Yes. Are you on the second curve? Make sure you're on the straight line. Yes. And then get over to the corner that you, or the intersection point that you haven't found yet. 4.525. 4.525. 4.525. And that's seconds. Seconds. What's happening to my cursor? There we go. All right. So we can find the time is in between 2.2 seconds and 4.5 seconds. So if we had to figure out how long was it above 50, we would just subtract these two numbers. 2.3 seconds above 50. It was above 50 for 2.3 seconds. And there we go. So I did one of each kind, and the difference is this. Remember that gravity is 32 feet per second. The acceleration of gravity is pulling you down. When you throw something up, it pulls it down that speed. And then 9.8 meters per second if you're measuring in meters. So just depending on what the question asks, this one's dealing with meters. 1,000 meters up, he drops a bag of sand. So that's at the top. He's already at the vertex. He drops the bag of sand. The sand falls to the ground. How long does it take? You know, that's the kind of deal. What this one? Here I've got a cannon. It's shooting something up, but the velocity is measured in 384 feet per second. So this one, you'd have to use this number for gravity. So just depending on what's written in your problem, you have to use feet or meters depending on the value for g. Right? Then all the other numbers you just plug in the right spot. Velocity, height, and gravity, and you're done. You should be able to do today's homework without too much trouble. Goodbye.